Okay, so this is an ALEKS problem regarding rounding and regarding significant digits. It's one of the questions in the second objective, Chapter 1, Part 2. So this one says that we're rounding to a given significant digit. And the question says that a chemist needs to know the mass of a sample of MgCl2, magnesium chloride, to 2 significant digits. He puts the sample on a digital scale, and this is what the scale shows. 015.669 G. If this measurement is precise enough for the chemist, round it to 2 significant digits, meaning if 2 significant digits is good enough, round it to 2 significant digits. So in this one, let's write the number down here. And, oops, let me come back over here and put up my pencil. So 015.669 grams. G is abbreviation for grams. That's a mass unit. Now we only need 2 significant digits. Now one of the rules of significant digits is that any number between 1 and 9 is considered significant in a measurement. So the 1, the 5, the 6, and the 9, those are all significant digits in this measurement. But 0 is a little more complicated. In section 1.5 of your textbook, there's a list of 5 rules. And one of the rules says that leading zeros or front zeros do not count. So this one is not a significant digit. We ignore it in terms of our analysis. It's in the front, and zeros in the front are ignored. So I'm going to put in little numbers up here above each measurement number. I'm going to write count from 1 to 5, the number of significant digits. So the tens place, the ones place, the 10th place, the 100th place, and the 1000th place, 5 significant digits in this measurement. But we only need it to 2. So the second one would be this one right here. So if we didn't round, if we just truncated, we would just say it's 15. However, it says us to round it. So what we're going to do is we're going to look at the next digit, which is right here, and ask ourselves, is this 5 or greater? It is 5 or greater, so we round up. So this one goes up by 1 in the ones place. So 1, 6, and that would have 2 significant digits. Again, the 0 does not count, so that's not part of the measurement. So we would just round it to 16 grams. So the device, the digital balance, shows this, but if we just want to have the number reported to 2 significant digits, we would have this. So 2 significant digits. Suppose we wanted to have it to 3 significant digits. Well, then what we would do is we would come over here to the third digit. The third digit is a 6, so it's 15.6 if you truncated everything after it. However, the number that comes after that 6 is also 5 or greater, so we would round this one up by 1. So 15.7 would be the reported value if we wanted 3 significant digits. And if we wanted 4 significant digits, the 4th significant digit is right here. Again, the number coming after it is 5 or greater, so it gets rounded up to 7. So 15.67 grams, and that would be 4 significant digits. Okay? Now you could ask yourself one more question, was what if you just wanted it to 1 significant digit? That would be a little bit odd. Most of the time people would want at least 2. But suppose it was okay and you just wanted it to 1 significant digit. Well, again, the first significant digit is the 1 in the tens place. The next number after it is a 5. So that's 5 or greater. So you would round the tens up by 1 and you would have a 20, right? That would be 2 significant digits. Now here's an issue that comes up. I'm sorry, that'd be 1 significant digit. If you have 1 significant digit, but you have a 0 here, how do we deal with that? Is that significant or not? Well, one way to deal with that is just to put a decimal point after, and that would say that this one counts. So the rules of 0 on the right side, on this end, we call them trailing zeros, is a little bit more complicated. If there's a decimal point, it definitely counts. If there's no decimal point, it's not clear. So if we write 20 grams, it's not really clear whether we mean that it's 1 or 2 significant digits. So one way out of this issue is if you put the decimal point, you have 2. If you don't put the decimal point, we don't know whether it's 1 or 2. So the one way that's dealt with is with scientific notation. So if you convert this into scientific notation and just write 2 times 10 to the 1 grams, the 10 to the 1 is not an issue of significant digits. That's just placeholders, powers of 10. But the 2 is the decimal number, and that's actually the significant figures there. So this particular measurement, 2 times 10 to the 1 would only have 1 significant digit. So that's how you could get out of that. But it's a little bit more complicated with 0 at the end there.